the next concept what we have is meant by velocity. Now let us see the definition of what the velocity is. The velocity of a body is the rate of change of displacement with time. We have seen what is speed is. What is speed? Speed is nothing but distance by time. The rate of change of distance with respect to time is called as speed. What was the distance? Distance was a scalar quantity. Right? Since what about the speed? Speed was also a scalar quantity. It means we need to consider only the magnitude but not direction. But what about the velocity here? Velocity of a body is rate of change of displacement. What it is? Displacement. Since displacement is which quantity? Displacement is a vector quantity with time in a specified direction. Look here. When does we consider direction? In the case of vector itself, we consider what is direction. The magnitude itself is not enough. Both magnitude and direction is needed. Hence, how can we define a velocity? The velocity of a body is the rate of change of displacement with time in a specified direction. If it has a direction, it is called what we mean by velocity. Understand? Mathematically, velocity we can write velocity as rate of change of displacement by time. We know that velocity is denoted with the letter V and arrow mark above it. Why? Since it is a vector quantity. What about the displacement? If I just write as it's a distance, for displacement what I should write? It's an arrow mark since it is a vector quantity. And what about time? Is it not? And one more thing you need to understand, velocity no doubt is denoted with the letter V and an arrow mark above it. But when we are solving in numericals, we get two types of velocity. That is not much different. That is initial velocity and final velocity. So always for initial velocity, we consider initial velocity is denoted with the letter U, with an arrow mark. Understand? U to be the initial velocity. Then what about the final velocity? For the final velocity, we consider nothing but V arrow mark. Understood? This we take in the case of numericals. Usually we denote with the letter V arrow mark cap. That's the velocity. If we just write V, it becomes speed. Did you understand? This both we take in the case of what we mean by numericals. Next, we already know since velocity is having both magnitude and direction. Velocity is what quantity? Velocity is a vector quantity. Velocity is a vector quantity. Understand? It is a vector quantity. Then what about its SI unit and CGS unit? What about its SI and CGS? In the case of speed, you remember what is the SI and what was the CGS? In the case of speed, SI was meter per second. What about the CGS in the speed? Centimeter per second. Here let us quickly find out by using a formula. Now we know that displacement is denoted by what is the unit? Meter. What about time? Always in any of the units it is second. So like speed, even the SI unit of velocity is meter per second or it is ms minus. We can write in both ways. Then what about obviously the CGS? CGS unit of displacement is nothing but centimeter per second or it is understood. This is the complete thing of what we mean by velocity. In a numerical, sometimes very simple numerical is they give you the displacement and time and ask you to find velocity. Sometimes remember always when we are solving a numerical, it should be there in SI units. But sometimes they will not give in SI units. They will give in CGS units. The first very thing we need to do is that convert from CGS to SI, then solve the problem. Understand? Sometimes they will give you in even kilometer per hour. This is not a SI unit. We need to convert from kilometer per hour to meter per second. Or sometimes they ask you to do the problem in meter per second. We need to find out in meter per second the velocity, and at last we need to convert to kilometer per hour. How to convert from kilometer per Meter per second to kilometer per hour we will see in the numerical section. Understand? So what was the SI unit here? Meter per second, and the CGS unit is centimeter per second, which is always same as that of speed. Now, to know about the velocity much further, we need to consider three cases. Those three cases, if you understand very well, we need to understand all the types of velocity very easily. You know, already we have seen the types of speed. Which was the types of speed? Uniform speed, non-uniform or variable speed, instantaneous speed, average speed. The same type of speeds comes in the case of even velocity. But if you understand it, it's very easy. But slight, what is the difference between speed and velocity is speed has no direction, velocity has direction. Now quickly let us see what are the three cases. Then you will understand why. So let me take case 1. In this case, I am considering two bodies here. Consider a car A, and one more car B. Understand? Car A and car B. This car is moving with the speed of 50 km per hour. What it is? 50 km per hour. The speed is nothing but magnitude. And what is the direction? Which is the direction towards your right? We already see the directions. This is north, south, east and west. So which is the direction? This is east. Even the car B also is traveling towards the east. Since it is moving with the same speed and in same direction, even let us keep the time to be of same. They both are traveling with 2 hours. They both travel in 2 hours. Look here, we have same magnitude, same direction, same time. When an object, when a body moves in a same magnitude, same direction, same speed, then we consider we will be having, it is moving with same velocity. The both A and B car is moving with same velocity, or it is also called as uniform velocity. It is moving with uniform velocity. Why? Because you know velocity what it is. Velocity is nothing but what? Rate of change of displacement by time. Displacement by time in the sense, since it is a vector quantity, we need both magnitude and direction. Look at the magnitude is same, direction is same, even with respect to time. Right? So even time I am considering the same. All the three parameters are same. Hence we can tell that both car A and B, it is moving with the same velocity. Did you understand? Now let us move to the case 2. Consider the same car A and B. This is car A. This is car B. Now, car A is moving with 50 km per hour. The car B is moving with 40 km per hour. Both directions let us keep the same. That is east and east. Time also let us consider for 2 hours, and it is 2 hours. What is the difference between case 1 and case 2 now? Just see that here we have magnitude 50 and 40. Here the magnitudes were 50 and 50. Both the car A and B's magnitudes were same. Here it is different. But what about direction? Direction is same, and even what time is also same. But what it is changing? The magnitude is changing. Hence, in any of the three quantities, if one parameter changes also, it is not moving with the same velocity. Obviously, we can tell, see, for 2 hours it might move 50 km. It is moved only 40 km per hour. Hence, we can tell the velocity is variable. It is moving with variable velocity. You are understanding? Now let us consider example 3, or what you mean by case 3. Again you take car A and car B itself. This is car A moving with 50 km per hour towards east in 2 hours. This is the case. Now let us consider this is car B moving with same 50 km per hour towards west direction, and it had been given in 2 hours. Did you understand? By this time you should have understand what the case 3 is. Same car A and car B I have taken. Car A's magnitude is also what? 50. Car B's magnitude also 50. But what about the direction? Car A has a direction, it is moving the direction of east. This is moving the direction of west. But what about time? Time is being same. Since here the direction has changed, magnitude remains constant, and time also it is same. If any one thing I have already told, in the parameters of magnitude, direction and time, if any one thing changes also, the body is not moving with the same velocity. Understand? Hence in the case 3 also we can know that velocity is variable or non-uniform. Velocity is variable. Now let us see the types of velocities whatever we have. As a type of speeds, the first one is obviously uniform velocity. In a velocity, in the speed also we had first one, which is the first type of speed we had. We had uniform speed. In the case of velocity also, it is uniform velocity. What was the uniform speed? If a body covers equal distance in equal intervals of time. There we didn't mention direction. Why? Since speed is a scalar quantity. I have repeated you 100 more times. But what about velocity? Velocity is being a vector quantity along with direction. Along with magnitude, we need even direction. That is what here. Look at, if a body travels equal distances in a particular direction, we are mentioning the direction here. Since it is a vector quantity in equal intervals of time, then the body is said to be moving with a uniform velocity. Remember the case 1, just now we have seen. I have considered car A and car B. What it was doing? Both was going in a 50 km per hour. Magnitude is same. Both were moving towards which direction? East. Therefore direction is same. What about the time? Both were traveling with a time of 2 hours to move 50 km per hour. So all the 3 parameters were the same. Right? Here also, if a body was car in our case, travels equal distances in a particular direction. They both traveled equal distances of 50 km per hour in a particular direction. Which direction? East. In equal intervals of time. Is it not? It was not the equal intervals of time. What was the time I have taken? 2 hours. Then the body is said to be moving with a uniform velocity. Understand? Then the body is said to be moving with a uniform velocity. Very simple. Now, one more thing we need to keep. I have taken in the case of uniform speed, a bus which is moving from Bangalore to Hyderabad. Why I can't take the same type of example in the case of velocity is that doesn't matter. Why? Because you know that for a velocity, a body should always travel in a straight line to have a uniform velocity. But the road from Bangalore to Hyderabad is very much straight itself. The bus never takes a turn. Bus takes a turn lakh times, maybe probably to reach from Bangalore to Hyderabad. Suddenly, if there is, for example, the bus is moving here for 1 kilometer. Suddenly there was a circle to move this. If a bus changes here, the direction, velocity changes. What happened to the velocity? Velocity becomes different. So we are not going to take such type of examples. Even the car example what I have given, 50 kilometers, they all were traveled in a straight road itself. There was not a simple curve they have taken. Then only it comes under what? uniform velocity. For speed it doesn't matter. Why? Speed is not having any direction. So the bus can take any turns and move. It reached. That's what is known as uniform speed. But what in the case of velocity? Velocity, there should be no change in its direction. Understand? So we have one example for what we mean by uniform velocity is this you all know very well. The raindrop reach on Earth's surface. The Earth's surface falling with a uniform velocity. See the example what we have taken is the raindrop. You know that raining rain how the raindrop goes upward. Obviously we get a rain from the clouds. So obviously the raindrops comes down. What we take, the raindrop reaches the Earth's surface. What they are telling, the raindrops reaches the Earth's surface falling with a uniform velocity. So if the raindrop is falling with the same uniform velocity, what does it mean? The distance, the time and what? Direction, all the three parameters is same in the case of velocity, in the case of raindrop. Here you can ask me a question, that is it not any other force which has been acting on a raindrop to come with a uniform velocity? How can it come? Because there is a lot of air which is putting a force, opposition force in the case of raindrop. But why this is not happening is because the viscous force, because of the viscous force or viscosity, what we call the concept of viscosity and upthrust force, what is acting on a raindrop becomes zero. All these forces, the net force which is acting on a raindrop makes it to be zero. Hence what happens, this raindrop reaches the Earth's surface falling with a uniform velocity. Remember, if it is coming with a uniform velocity means there is no change in its direction at all. See that. For example, think that if raindrop is coming, it just comes down with the same direction. Does it go like this? Then it comes like this? No. If this happens, the change in direction, the very next moment there is change in its velocity also. Hence, we will not consider this to be a uniform velocity. In the case of raindrop, what happens? It comes with a straight direction. Understand? So hence, this is an example for what you mean by uniform velocity. Understand? Now let us move with what we mean by non-uniform or variable velocity. What was in the case of speed? What was a variable speed or non-uniform speed? If a body covers unequal distance in equal intervals of time. Again, I have taken the example of bus. For 2 hours it traveled 200 kilometers. For the next 2 hours it traveled 300. Then the last 2 hours it took only 100. In that case, everything is okay. Why? Speed doesn't matter with the direction. But in the case of non-uniform or variable velocity, velocity is matters with always direction. Let me take here. Let us go with the definition. If a body travels unequal distance in a particular direction, which was the case 2. If a body travels unequal distance, I have taken 2 cars. One car moved with 50 km per hour, the other car moved with 40 km per hour. So unequal distance in a particular direction, which was the direction east, in equal intervals of time. Obviously 2 hours. I kept the time constant. So this was in the case of case 2. Now or equal distances in the case of case 3. Both moved 50 km per hour in equal intervals of time. Again the time was 2 hours with the change in direction of motion. Yes, car A moved with east, car B moved with west. You can go through again and see the case 3 cases. Then you will understand very well what is uniform. Case 1 belongs to uniform velocity. Case 2 and 3 comes under non-uniform or variable velocity. Understand? So we need to see if a body travels, if it travels unequal distance, means the magnitude is unequal distance. The magnitude is changing in a particular direction. Direction is remains constant and time also constant. Or equal distances, magnitude is same, but equal intervals of time. Time is also same, but what is changing? Changing direction of motion. The direction is changing. All the 3 parameters are not same in the case of non-uniform or variable. Any one is being changing. Or even you can consider even time can be changed. Keep direction same, speed same. If you change in time, again that leads to non-uniform velocity. All the 3 parameters should be the same. Understand? Then only we get uniform velocity. Otherwise it is non-uniform or variable velocity. So I have two examples here which is given in your same textbook too. I will explain you this. See the example one. Motion of a free falling body. Now think this is chalk. A motion of free falling body. See this ball or anything which is at a height now. Obviously, right? I have kept in a certain height and I made to fall this to a floor. I made to fall it. So what happened? It falls and come and places on the surface. Did you understand? Here, what is the direction of this? According to map, if you consider north, south, east and west. Let us consider it is moving in the direction of south. One parameter satisfied. Understand? What is the time interval you just consider? In this time it is moving with some time t. But what happens with the speed of this? Speed is changing. What it is? Speed is changing with respect to time. The speed is changing with respect to time. You obviously know that. Do one thing. You go on the top of your home. Take some of your bicycle keychain. Ask your brother to be down and ask him to catch it. When the time when you catch, when you leave the keychain on the floor, it will be coming. But when it comes to his hand, it will get very much pain. The reason is that when the body is coming near to the cover, the acceleration due to gravity on a body is more. It will be acting square times. So hence what happens? The speed is very maximum when it is near the earth. So what happens in this case? The body speed is keep on changing. Even the direction is same, time is same. If you keep the time, what is changing here? Speed is changing, means magnitude is changing. Understand? Among the three parameters, if one changes also, what happens? It is not moving with a uniform velocity. Hence, this is an example for non-uniform or variable velocity. There is one more example we can take, that is motion of a body in a circular path. Motion of a body in a circular path. Let us take, already we have studied in the case of displacement. What will be the displacement in the case of circular path? 0. What will be the distance? 2 pi r. So the same way, let us take now motion of a body on a circular path. Consider this is circular path. The body is here at a time. Let me take four places: A, B, C, and D. Understand? Now a body is moving from A to B, then B to C, C to D, and back to A. This is what the condition I am taking, motion. So now, when the body is at A, it is in the direction of north. What it is? It is in the direction of north. You can know that. According to map, the upwards is what? North. So when it comes to the B position, what happens? It is towards west. When it is a C, it is towards south, and when it is a D, it is towards east. You can see all the four positions. All the four positions, the direction is changing. Then what about its body which is moving in a circular? If the direction changes, what changes? Velocity changes each and every time. Understand? Now for example, the time taken by a body to move from A to B is 3 minutes. B to C is 3 minutes. And C to D also 3 minutes, and B to A is also 3 minutes. Here, what I am making the constant, time is constant everywhere. The time taken by a body to move from A to B also same. B to C is also 3 minutes, C to D, D to A. Here I have kept time is constant. Then always remember, in a uniform circular motion, one thing is constant, that is speed. Speed is same in a circular motion. Since speed is same, the magnitude is same, right? The magnitude is same in this case and time is same in this. But what is changing? Which parameter is changing? Direction. At each and every moment, the direction of an object which is moving in a circular path keeps on changing. If direction changes, what do you mean by it? It comes under non-uniform or variable velocity. Understand? So this is an example for non-uniform or variable velocities. Non-uniform or variable. Understand? When you come to your next year class also, you have this chapter in case of force. Uniform circular motion and uniform linear motion you get. You will understand this concept much better there. Your understanding in a uniform circular motion always remembers speed is same, time is same, that is magnitude is same, and time is same, but what is changing? The distance or direction keeps on changing at every moment, hence it comes under non-uniform motion. In this case, the speed is changing at every moment. A free fall body which has been moving, so direction remains same, time remains same, hence it comes under non-uniform, or what do you mean by variable velocity. Next we have what you instantaneous and average velocity. We will discuss it now. So the next type of velocity what we have is instantaneous velocity. Even in the case of speed we have seen, it's also a type of speed, instantaneous speed. How do you find the instantaneous? At any moment when a body is traveling, the time, what is the speed at particular time gives you what we known as instantaneous speed. What is the instrument we use to find the instantaneous speed? The speedometer of the vehicle. For example, when you will be traveling with 50 km per hour, suddenly a humps come, then your speed reduces to 20 km per hour. That instant, what was the speed? That is 20 km per hour. It is known as instantaneous speed. The same way, the instantaneous velocity also. That is for a body moving with variable velocity. Now let me consider simply in a circular motion itself. A body always moves in what? A body which is moving always in a variable velocity. Why it is moving in a variable velocity? Because there is always change in a direction. For example, when it comes here, the direction will be this. When it comes here, the direction is here. When it is always, it will be tangential. Always it will be tangential. So we can tell that the body which is moving in a uniform circular motion always changes its direction. So when it is changing its direction, we know that there is a change in variable velocity. So the velocity of a body at any instant is called as instantaneous velocity. See, for example, think it was here, the body. If I measure its velocity, what? That velocity at that particular time is known as what you mean by instantaneous velocity. At any way you can take it. At all the places. However, there is a variable velocity in the case of uniform circular motion in a circular path. What remains constant? As I told you before, speed remains constant, but always the direction changes, the velocity also changes, because velocity depends on changing direction, and hence even this is called as accelerated motion. That concept we will come up with the next time. Did you understand the instantaneous velocity? Same way as defined of speed, instantaneous speed. We have instantaneous velocity. If we want instantaneous velocity, we need a body which is moving with a variable velocity. Here I have considered a body moving in a circular. So the last type of velocity what we have is average velocity. Even in the case of speed we have, what was the average speed? The total distance covered by a body by total time. The same way that average velocity is. Let us see that. If a velocity of a body moving with a particular direction, here why the direction comes? Why not in the case of speed? It is a scalar, this is a vector where direction is important along with magnitude. Direction changes with time. The ratio of displacement to the time taken in the entire journey is called average velocity. This can be given mathematically as average velocity is equals to displacement by time, total time. So in yesterday's example we have seen in the case of displacement video. That is, for example, your home is here and the school is here, right? You are moving in a shortest path is always considered to be the displacement. So your displacement considered to be of 50 meter and you are taking 100 seconds to reach from home to school. So in this case, what is the average velocity? Easy to find. Average velocity, the displacement is how much? 50 meter. What is the time taken? Is 100 seconds. Therefore, 0.5 meter per second is the velocity, average velocity. Even, for example, you think you went from home to school and you came back from school to home at the evening. What is the displacement at that time? We know displacement is 0 because initial position and final position is the same. So at that time, how can you find the average velocity? At that time, average displacement was 0 by think that 100 seconds and coming back is also 100 seconds. So overall it is 200 seconds. But 0 by something gives you 0. But in that case, average velocity is how much? 0. Why? Since the displacement is 0. Remember one thing, average velocity can also be 0, but average speed cannot be 0. Distance cannot be 0. Displacement can be 0. That's the only difference what it is. Understand? So this ends the concept of what you mean by velocity and its types.